Okay, so basically in-order tree traversal means that all of these nodes, as you can see here, this is my root over here. All of these nodes are traversed and I will return all of these values in order, ascending order. So by that logic, I should return the value 4, 10, 12, 15, 18, 22, 24, 25, 31, 35, 44, 50, 66, 70, and then finally 90. That's my in-order tree traversal. But how does that take place? Basically, what happens is that I will first access individual nodes. I will access left nodes until I reach the final node. Okay, I will access nodes towards the left until I reach my final node. So basically, I will start at my root node. So the procedure states that I will access the root node first, and I will check, is there anything on the left of my root node? Okay, so anything on the left of my root node is yes, there is something. This is node here with 15 in it. Okay. Now let's just say for a minute that this is my new root. I'm going to call this as a root now, another root. Okay. Is there anything on the left of this root? Yes, there is. The node with the value 10 in it. Okay. I'm still accessing the nodes. I'm not returning, I'm not outputting anything. I'm simply accessing the lowest node. Okay. Now I'm here. Is there anything on the left of this node? Yes, there is. There's node number this with the 4 value in it. Now this will be my new root. Is there anything on the left of this? No, there is not. So now this root has nothing on the left. So since I have nothing on the left on it, I can do what? I can say that there's nothing on the left, output this value. I will output. So if there's nothing on the left anymore, I have reached the leftmost position. I will output this. So at this on the screen, it will be written 4. So going back on the upper root, am I done with the left of this root? Am I done with the left of this root? Yani 10. If I am done with the left of the root number 10, yes, I have. I have output 4. So the procedure says that if you have output the left of a root, you can proceed on outputting the right of the root. Okay, by that logic, if we come back here, is there anything on the left of this root? No, output 4. If you're done with outputting the left, you will output the root and then you will output the right. Now this is a leaf node. There's no left or right. So there's nothing to output on the left. So I don't do output anything from the left. I will simply output my root, then I'll output towards the right. So again, repeating my previous statement, that first you will output the left statement node, then you will output the root node, then you will output the right node. Now, since for 4 as a root node, there is nothing on the left, there's nothing to output. There's nothing output on left, I will output the root node. There's nothing to output on the right. So that means I'm done with this small tree. If you call this a subtree with no left or right nodes, I'm done with this subtree. Okay, by the way, this subtree was the left of this root. So if I'm done with the left of this root, which is 4, I can proceed on outputting the root itself, that is 10. So if I'm done with the left, I'm done with the root, I can go towards the right. Okay, now let's start looking at this as another root. Is there anything on the left? No. So output the root itself. Is there anything right? No. So that means I'm done with this. Since I'm done with the right of this node, I'm done with this complete tree. Think about it. If this was the root, I'm done with the left, I'm done with the root, I'm done with the right. So that means I'm done with this complete tree. If I'm done with this complete tree, that means I'm done with the left of this root. Of root 15, I'm done with the left of this. So if I'm done with the left of 15, I can proceed on outputting 15. So left output first, then the root, then move to the right. So I have output 15. I will move to the right. Is there anything on the left of this road? Yes, there is. 18. Is there anything on the left? No, it isn't. So output 18. I've output the left of this root 18. I will output the root itself 22. I will then output the right of this root 24. Since there's nothing on the left or right, I will simply output this. Since I'm done with the right of this root, that means I'm done with this entire subtree. And since I'm done with this entire subtree, it means I'm done with the right of 15. Since I'm done with the right of 15, it means that I'm done with this entire tree. And by being done with this entire tree, it means that I'm done with the left of 25. Since I'm being done with the left of 25, I will simply output 25, the root now. So first take care of everything on the left of 25, then output 25, then go towards the right. So when I go towards the right of 25, I end up with the root as 50. Is there anything on the left of 50? Yes, there is. Now think of this as a separate tree. 50 is the root over here. Is there anything on the left of 50? Yes, there is. Think of this as a separate tree on its own. Is there anything left of 50? Yes, there is. Is there anything left? No. Output the root 31. Output, there is anything on the right? No. Since I'm done with this thing, this subtree, it means I'm done with the left of 35. Since I'm done with the left of 35, I will output 35. Since I'm done with 35, I will proceed towards the right of 35. That is 44. Is there anything left of 44? No. Output 44 as the root right now. Is there anything on the right? No, there isn't. Since I'm done with 44, it means I'm done with the right of 35. Since I'm done with the right of 35, it means I'm done with this entire complete subtree. Since I'm done with this complete subtree, it means I'm done with the left of 50. It's now the time to output 50. I will output 50, move towards the right. This is my new root. Is there anything on the left? Yes. Is there anything on the left? No. Output this as the root. Is there anything on the right? No, there isn't. I'm done with this. If I'm done with the left of 70, I will output 70. I'll move towards the right. If I'm done, if I see there's anything on the left of 90, no, there isn't. I will output 90. Is there anything right of 90? No, it isn't. If I'm done with this right of, if I'm done with 90, that means I'm done with the right of 70. If I'm done with the right of 70, it means I'm done with the right of 50. If I'm done with the right of 70, and it means I'm done with this complete subtree, and this complete subtree is the right of 50. If I'm done with the right of 50, it means I'm done with this entire subtree, which is the right of 25. And if I'm done with right of 25, I have output all of the nodes. Now, if you followed the sequence closely, what happened was that first I reached the left, then the left, then the left, and I reached 4 first. I outputted this first. Output the left, then the root 10, then the root right 12. I'm done with the entire left, output the root 15, then the right, then the left 18, then the root 22, then the right 24. I'm done with the entire right. I will go towards the root 25. I'm done with 25, proceed towards the right. Left 31, output the root, output 44, the right. I'm done with the entire left, output the root 50, move towards the right, goes towards the left of this root, output 66, output the root on its own, output 9. And this will be my final output. So this basically is my in order tree traversal. And as you can see here, that's the output I'm getting from here as well. Now, this is the basic flow of things. This is what's basically happening. Now we'll look at what's really happening and why is this implemented through recursion in this algorithm.
All right.
Now let's look at how recursion is being used in order tree traversal to achieve all values being output in order. So first of all, my first procedure call. So this is my procedure. This is known as def. And by the way, I'm defining this procedure. This is the procedure definition. And you can see print in order is the procedure's name. And I am also calling this same subroutine within my procedure definition. By the way, yes, this is procedures. This is not being returned anything. So this statement means this if root means that if root is not equal to null. So if it is actually a not null value, then this procedure will carry on. So by the way, this is sort of my general case. That means it will cause cause a recursive call. So if my root is null, that will be my base case, and it's not mentioned here, but that basically results in the end of a recursive sequence. Now let's look at what's happening here. Obviously, since my actual main root is the node with the value 25, that is what I am passing here. This will be my past. This will be passed as my original root. Is the value 25 null? No, it isn't. It's a not null value. So I'm still at the general case. Okay, what I will do is that first I will have to pass the sequence states, go left first, then the root, then right. So to achieve first output 25, I will have to first output the left, everything left of 25. So for 25 as the root, I will have to first go towards the left of the current root. So basically I will pass the left of 25, which is 15, to this procedure. And now this results in a recursive call. Now I'm passing 15 as a parameter. This is my second recursive call with 15 as a parameter. Okay, is 15 null? Not null? Yes, it is. It's true. So I will start executing my third procedure call, third recursive call. In this case, I'm passing the left of 15. I'm accessing the left of 15. Now the left of 15 is this node over here. I pass this node as a parameter and I come back here for another recursive call. Is the value 10 not null? Yes, it is. So that means no base case is still a general case. I come here, I pass the left of 10. The left of 10 is passed, and now the node 4 is passed as a parameter. Is 4 not null? Yes, it is. Now I will pass the left of 4. Now this time around, I have passed a null value because there is nothing on the left of 4. Now I have passed a null value. Now, when that null is passed for another recursive call, this root will hold a value null now. In this case, you see, this condition will become false. And there is no else to, so it basically does nothing. There's no outcome. So the base case has been achieved, and base case means it does exits the code. So for the root, the left of 4, since it's null, there is no execution. So root, the left of 4 results in no action because it's null, and I will simply exit this code. So now right now, currently my root is 4. I'm at that layer when my root is 4. I'm at this position. So there is nothing at the left of my root. So nothing will happen over here, no more further recursive call. And I will simply exit this condition and I will print the value of that root, which is 4. The value of 4 will be printed out. After the value of 4 is printed out, I will proceed towards the right because that's the rule. First print the left, then the root, then the right. So my root is currently at node number 4, and I will pass the right of root 4, which is again null. So again, this null is passed for another recursive call. That null ends up here. This condition is failed. The base case has been achieved, and nothing comes out of here. By the way, that means that the root for the right of 4 is also finished. The right of 4 is also finished. I've outputted the value with node 4 in it. I have outputted 4 on it, and the value right of 4 has also been output. By the way, the right of 4 completed means this 4 node is completely finished. And if 4 node is completely finished, that means I'm done with the left of 10. So we come back a layer upwards. So now my root is back at 10. Okay, I'm back at 10. So 10, the left of 10 is done because I've achieved everything from 4. I've output everything from 4. The left of 10 is done. The left of 10 is done. Now I'm a layer up. Okay, the left of 10 is done. So that means I can now output the value at node number 10, in which case 10 will be output. And after the root is output, I will move towards the right of 10, in which case my 12 will be passed as a parameter. Is 12 null? Yeah, no, it isn't. So this condition is true, in which case I will pass the left of 12, which is null, which will result in no output. I will output 12 itself, And then I will pass to the right of 12, which is also none, to this recursive call, and which will also result in no result, nothing being output. So by the way, if I'm done with the right of 12, that means I'm done with this tree, this small tree with the 12 as the root. It doesn't look like a tree, but it actually is. It has nothing on the left and right. It's a leaf node. But if I consider this as a root, I'm done with this subtree because I just got through outputting the right of 12, which is null. It does nothing. So since I'm done with the right of 12, it means, and the upper layer, I'm done with the right of 10. I'm going back a layer up. I'm done with the right of 10. Now, since I'm done with the right of 10, it means I'm done with the left of 15. One more layer up. Now I'm back at 15. I'm done with the left of 15. Since I'm done with the left of 15, I can proceed in outputting the value of 15, and now 15 will be output on the screen. After I'm done with outputting root 15 value, which is 15, I'll move towards the right of 15. Now I'm passing the right of 15. Now this time I'm passing the root 22, the node with 22 in it. I will be passing that as a root. In this case, that 22 is passed in a recursive call. Is 22 null? No, it is not. That means this code will run. First, I will pass the left of 22, which is 18. Another recursive call enters. Now 18 is my root. Is 18 null? No, it isn't. So I will pass the left of 18, which is now null. Now this null is passed in this left of 18 procedure. Does it do anything? No, it doesn't. I will simply proceed, and I'm at 18 root now. I'll simply proceed on outputting 18 here. The value 18 will be output. Then I will proceed towards the right of 18, which is also null, doing nothing. I'm done with 18. I'm done with the right of 18. Since I'm done with the right of 18, I'm done with the left of 22. I will output 22. I will proceed towards the right of 22, meaning I will pass 24 as a parameter. Now 24 is my root. It's null. No, it isn't. I will pass the left of 24, which is null, does nothing. I will output 24. I will output to the right of 24, which is also null, does nothing. Since I'm done with the right of 24, it means that I'm done with the right of 22. Since I'm done with the right of 22, go back one layer up. I'm done with the right of 15. Since I'm done with right of 15, go back another layer. I'm done with the left of 25. Since I'm done with the left of 25, I will output 25. And then I will proceed on passing the right of 25, which is 50. Since I'm at passing 50 right now, now 50 is my root, I will pass the right of 50. 35 will be passed. I will proceed towards 35 as a root now. It's not null, yes. I will pass the left of 35, which is 31. Now 31 is my root. I will pass the left of 31, which is null. It does nothing. So the left of 31 does nothing. I will output 31. I will pass the right of 31, which does nothing. So that means if I'm done with 31, it means that I'm done with the left of 35. I will output 35. Since I'm outputting 35, I will pass the right of 35, which is 44. Now 44 is my root. There is nothing on the left 44, do nothing. There is the value 44 being output. There is nothing on the right of 44, do nothing. So that means if I'm done with 44, I'm done with the right of 35. If I'm done with 35, it means I'm done with the left of 50. That means now I will output the value 50. And finally, when I'm done with outputting the value 50, I will move towards the right of 50. Now I'm at the right, I'm at 70 as a root. So I pass 70 in my recursive call. I have root 70 as my, I have 70, the node 7, the node with the value 70 in it as my root. I'll pass towards the left of this node, which will end up with the node with 66 in it. Now the node with 66 is my root. The left of that is null. It will do nothing. I will output the value, which is 66. I'll move towards the right, which does nothing. So if I'm done with 66, that means I'm done with the left of 70. I will output 70. If I'm outputting 70, I'll move towards the right of 70. This time the node with the value 90 is my root. Is there anything on the left of 90? No. Output the value 90. Is there anything on the right of 90? No. I'm done with the right of 90. That means I'm done with the right of 70. If I'm done with the right of 70, that means I'm done with the right of 50, a layer back up. If I'm done with the right of 50, that means I'm done with the right of 25. And that's where I'm done with the entire algorithm. So in the last unwrapping, my root will be the node with 25 in it, of course, where we started off. And the right of 25 is completely finished. And since the procedure states left, then root, then right. So since I'm done with the right of 25, that means I'm done with outputting all values. Now, if you understood this, and if you notice that I outputted all values in order, first 4, then 10, left, root, right, 4, 10, 12, left, done, root 15, then right, then the left of this 18, then root 22, then right 24. Left is entirely done, 24 is output, root is output, then move to the right, left, left, 31 output, root output, right output, 31, 35, 44. I'm done with the left entirely, output 50. Then move towards the right, I have to move towards the left first, then again to the left, there's nothing here, output 60 after 55, 50. Then after 66, I will output 70. After 70, I will output 90, and that's where it ends. As we've just discussed the Python code, this is your pseudocode version of the exact same code. So you will see some similarities here. So basically, procedure is traverse tree. I will pass a pointer of type integer by value. So as long as my pointer is not equal to null, then this subroutine will carry out. So by the way, this is my general case. And as you can see here, there is no else state. And if the pointer is null, I will simply exit this procedure. And that will, the null value means the base case. And I will exit this procedure. But since my not null value causes a recursive call, it will be called my general case. So within my subroutine, you see, I will call another I'll make another recursive call. First time with the left pointer, I will handle with the left pointers first. I'll go left, left, left. Then I will output the root data. Then I'll output the right values. And then I'll go a layer up again. And I will carry on until all of the nodes be null. So exact same sequence of events that took place over here. But this time we're just representing it as a pseudocode. So exact same thing. So basically what you have to understand is what's this is all of just these 3 lines basically. So first you're traversing towards the left side, and then you're outputting the data at the root, then you're traversing towards the right side. And when you're done with the right side as well, that means you're done with an entire layer and you go back 1 layer up and so on and so forth. So exact same code that's just written in pseudocode. And this is, in a sense, your in order tree traversal. And this is what your binary tree requires. This is another feature of your binary tree in which all of your nodes are accessed and all of the values are output. And again, they're output in order. And for this, you had to first understand what recursion is, because recursion is being used over here.